Hello, and welcome to Backer Breaks It Down. Today's episode, we are going to identify and apply relationships of angles related to a circle, with a focus on those angles whose vertex is on the circle. Because whenever you go to find an angle or arc measure in a circle, you should really ask yourself the question, where is the vertex? Okay. So we've previously worked with angles whose vertices are on the circle. We called them inscribed angles. And as you know, an inscribed angle, its measure is, well, half its intercepted arc. So another kind of angle that can have a vertice on a circle is a tangent chord angle. So over here on the right, this line is a tangent. Notice it's simply touching the circle in one place on the circle. And then AB is a chord. So the tangent and the chord make a tangent chord angle. And notice the vertex is on the circle. Now this tangent chord angle does create an arc. Okay, so like angle 1 creates arc AB. Angle 2 creates arc ACB. Bottom line is, the measure of a tangent chord angle, whose vertex is on the circle, is 1/2 the measure of its intercepted arc. So we can say that the measure of angle 1 is half the measure of arc AB. And if you really don't like working with fractions, even one as nice as 1/2, you can simply multiply both sides by 2, and that would give you 2 times the angle equals the arc. I like 2 times the angle equals the arc for algebra problems, but that's just me. So let's take a look at 2 examples, right? In number 1, line M is tangent to the circle. Find the measure of angle 1. Right? Well, angle 1 has a vertex on the circle, so I know that the angle is going to be half of the arc. That's the rule, so let's apply the rule. And so the arc here is 150 degrees. Notice that angle 1 is making that arc. Okay, so that means that the measure of angle 1 is equal to half the measure of the arc, which is 150, and half of 150 is 75. Pretty simple. Yeah? Let's try another one. In problem number 2, BC is tangent to the circle. Find the measure of angle CBD. So here we have some algebra. The rule is still the same. The angle is half the arc. Okay? So I can write an equation. I could be like the angle is 5x, and this is half of the arc, which is 9x plus 20. So you can see why like that 1/2, even though it's not that bad of a fraction, could be like causing you some anxiety here. So just remember, like it's all the denominator's fault. So if we go and we multiply both sides of our equation by 2, that will get rid of the 1/2. And now I don't have to worry about any fractions at all. I've got 10x equals 9x plus 20, and that means that x is equal to 20. Now remember, in geometry, whenever we have to solve an equation to find x, most of the time that's not the final answer. So always go back and look and see, is there anything they want me to do with this? And they want you to find the measure of angle CBD. Angle CBD is 5x, so I need to multiply 5 by 20, and so the measure of my angle is 100, and that's my final answer. So here we have the scenario of the vertex is on the circle, and when the vertex is on the circle, the measure of the angle is equal to half its arc, and that's how Backer breaks it down.